Oneness Evolving here. It's great to see you, and it's lovely to be outside in my front garden on this day. And you are going to hear some background noise because there's a construction site on the corner. So I'm not going to waste any time. I'm here out on my lawn because the Facebook Live has got to be, shared and show up. So while we wait for that, let me show you this. Because it's all here. It's all happening. This is the time in this garden when it is amazing and just full of flowers. And I just love being able to show it off to you. Share it. It's fabulous. And look at that. It's just the best. These are the Spiraxis. And they are crazy bright and beautiful, and there are just so many of them. And we have some bright pink ones in here. It's a bit hard to tell, but that is a hot pink as opposed to hot red. And there's so many. Those ones did used to be purple. Hello. But they've faded to white. I don't know why, but I rather like them like that. It's all just incredibly colourful here. So I love just being able to share this with you, getting along here, and then look at the magnolia. It's fantastic. The sun is just hitting all of the beautiful petals and colours, and the birds are singing. It is the best time in this garden. And look at the cineraria, they're so bright. And the fern in the back, and there's just nothing missing. It's really beautiful here. And if you think it's fabulous, look at this. Just zoom in on this granny's bonnet. Just a simple pink granny's bonnet, which is, I just love these. And then look, we have bluebells. And the cineraria, which I don't really arrange, they organise themselves, have just, they're so perfectly toned in this year. And this one bluebell, see, this one is lighter and it's flowered earlier. That one belongs in the back garden. These are the later ones, and they're bigger and they're just fabulous. So I got to move that one. I got to move it, but I didn't want to disturb everything just while it's all happening. So, I mean, look at this. It's glorious. So this is the time of year when I get to really celebrate spring with all these beautiful colours. And if you're on the other side of the planet and you're going into fall, well, you can appreciate this even more. And last but not least, look, the cherry tree is just starting. G'day, gorgeous. Lovely to see you. Just about to go inside, but it's so pretty out here. It's a blackbird singing. And the sun is obviously very bright. I just can't resist showing you this again. Look, it's gorgeous here. So I'm going to zoom in on the bluebells again because they're at their very, very best right now. And then I'm going to turn the camera around. You can look at me now. I'm going to go inside and tell you what I've been writing about and why I lost the plot and actually burst into tears this morning when I was writing, because what I was writing about was so mind-blowing that it's like the circuit popped. My brain could not handle what I was learning. So I'm going to share that with you now because it was really cool stuff. Just put the keys back, take my hat off. I'm going to hang my hat up. What do you know? All right, here we are in the lounge. I forgot to shut this door. And I'll just put my phone in a sensible place so I can relax and get my little notepad. It's all smoke and mirrors, really. I've got my phone propped up on a little thing, and here I am in my lounge. So here's my list of songs that I want to talk about today. So I did math last week, and you might be thinking, what the heck's this got to do with manifestation, and why are you talking about protons and atoms and other things and subatomic particles? I mean, really? But the thing is, if you want to change matter with your mind, you actually need to understand what the heck matter is, and most of us do not know. I really, I really had no clue what matter was or is. And, people say, oh, you think positive thoughts and you have a clear intention and you add elevated emotion, and I do that and it works. But there was this kind of craving inside of me that I didn't even recognize to understand how and why it works. And so that's what I'm trying to unpack now. So last week I was talking about atoms and electrons and protons, and one of the things that we established is that if you have a hydrogen atom, and hydrogen is a gas, and it's small and it's a teeny tiny thing, but if you scale that up, because I wanted to make it more obvious how much space there is in an atom, and if you make a hydrogen atom big enough that it's like the bit in the middle, the nucleus, is like the size of a Toyota Land Cruiser, which is actually too big, but we can think about that. It's the size of a Toyota Land Cruiser. And you stick that Toyota Land Cruiser in the middle of the whole of the state of Texas. The two electrons that are whizzing around that nucleus in the middle of the atom can be found somewhere in the whole of the state of Texas, and they're like peas. So imagine trying to find two peas in the whole of the state of Texas. And this Land Cruiser in the middle, which is actually way too big. It should be, the nucleus is a lot smaller than that. But the point being, there's an awful lot of space, right? And so that's the atom and the nucleus and the electrons. And most of us are sort of a little bit familiar with the atom and the nucleus and electrons. But there's another there are lots and lots of smaller subatomic particles. And you think, why is it important to even think about this? Trust me, it is. It's really, and it's so cool. This drives me up understanding this stuff. Shout out, big love to Nassim Haramein for discovering things, putting the pieces together, because the pieces are all there, but he's organised them, him and his team, in a way that even I can understand, although it takes a bit of thought. And the whole thing is starting to unpack for me. So this is what I'm trying to unpack for you. So, yeah, you have an atom and you have protons and neutrons in the nucleus and you have electrons whizzing around, and that's the atom. But there's a smaller thing. There is a much smaller thing called a Planck spherical unit, and they're named after Max Planck, and he discovered them. And they are really, really small. And all I've been trying to do in the last little while is explain how small they are. Because, protons, electrons, they're small enough. An atom's tiny, you can't see it. But a Planck spherical unit is really, really small. So where we got to last week is that if you imagine that the Planck spherical unit is the size of a grain of sand. A grain of sand is really small, right? And you stick that down on the ground and you get on a spaceship and you fly at light speed, which you can't actually do because you'll stop being matter if you hit light speed. But let's say you can. You fly at light speed for 4 years and 134 days, you will get to Alpha Centauri. That's the nearest, well, actually, Proxima Centauri is closer to Earth than Alpha Centauri, but I'm going for Alpha Centauri. So we go to Alpha Centauri, you get there, it's 4 years and 4 months later, and you might be thinking, why the hell is she talking about this? Well, if the grain of sand is the size of the Planck spherical unit, all that time that you've been traveling from Earth to Alpha Centauri, that's how big the proton is by comparison to a Planck spherical unit, which is pretty mind-meltingly huge, right? Because a proton's inside a nucleus, and the atom, state of Texas, Land Cruiser, proton smaller than a Land Cruiser. And now we're saying that the proton, which is that really small thing, is like from here to Alpha Centauri, and the PSU is like a grain of sand. So it's crazy, crazy, crazy scales, from the really small to the really big. And then I had a really scary thought, and at the end of last week I chucked some numbers, but I ran out of time. And I got crazy numbers and I didn't believe them, and I thought, I've got to work this out. So most of this morning I spent doing the math, because I suddenly thought to myself, hang on a minute, okay, if we say that a Planck spherical unit is the size of a grain of sand, and by comparison the proton going from one side of it to the other is the same distance as from here to Alpha Centauri, which is a long bloody time, it's 4.4 it's about 4 light years. Okay, it's a long way away. So if that's the difference between the Planck spherical unit and the proton, how big is the whole hydrogen atom? It's kind of like, oh God, do I even want to know? And I thought, how am I going to work this out? Because I started off thinking, the atom is 100,000 times. I said this last week. The atom is about 100,000 times the size of the nucleus. That's wrong. I checked all of my facts. It's 10,000 times. Generally, any random atom, but specifically the hydrogen atom was what I wanted to know. A hydrogen atom, the size of the atom is about 10,000 times the size of the nucleus. But we've only got the size of the proton. So then I had to go, well, how much bigger is the nucleus than the proton? And without driving you crazy, it's about twice as big across. So if a proton's this big across, the nucleus is roughly this big across. I'm doing really approximate things. I am not a physicist. I am a teacher. I want you to get the idea, not get buried in numbers and formulas and stuff. So the proton's this big. The nucleus is this big. Okay, so I know now that we can take the size of the proton, we can double it, and then we got the nucleus. And then we multiply by 10,000 and we have the size of the atom. Okay, that's math. I can do that. You have to be very, very careful because there's an awful lot of zeros involved and I'm not telling you about that. But because I had to write them all out so I could see them. I did a lot of math when I was at school and I loved it. And I'm really pleased that I loved it and I got good at it. So, okay, so you take the size of the proton, which remember in our scale model is the size of from here to Alpha Centauri. So that's 4.2 light years. Okay, so now it's on our journey from going from proton to atom, we go from 4.2 light years to 8.4 light years, or whatever it is. I've forgotten the number. I'm sorry. But then you have to multiply that by 10,000. So now we've got, 10,000 times 8.4 light years. So that, and again, forget the numbers, but it's big, right? No, actually, I wrote it down. So I finally got to this, that the distance across the atom in the scale model that we're working with, where you've got the Planck as the grain of sand and the proton is from here to Alpha Centauri, that the size of the atom compared to all of that would be 7.94 quintillion kilometers. And that is 7.94, or the 7, after the 7, if we just round it up to 8, if it was 8 quintillion kilometers, there'd be, I think, 18 zeros afterwards. Really big number. Okay, so it's an 8 with 18 zeros after it. What does that mean? So I thought, well, how do I make this mean something? And I thought, okay, well, from here to Alpha Centauri, that's a stellar distance. How big's the Milky Way? The galaxy we're in, right? Well, it turns out that the galaxy is 1 quintillion kilometers across, which means that in the scale model that we're using, where a grain of sand is the Planck, and from here to Alpha Centauri is the proton, the size of the atom is almost 8 times the size of the Milky Way. And I just lost it. There's so much space. And by the way, this is all happening in a hydrogen atom. 1 hydrogen atom. There's so much space, there's nearly nothing there at all. Now, the piece that I have not at all got to write about yet, because I'm not there yet, but what I'm experiencing, what I'm actually experiencing, and I'm learning, I'm studying now, I'm learning, is that all of that space is not empty. All of that space is full of energy. And by energy, I don't mean, I mean literally energy. I mean electrostatic charges that are moving and fluctuating and vibrating and doing stuff. And the only reason we can't see it or measure it with things that are made of the matter that we have here on Earth is because it's vibrating too fast to be matter. It's vibrating faster than the speed of light. And that's why you can't travel at the speed of light, because your body and you and everything just becomes particles again. It turns back into energy. Because you've got to vibrate slower than the speed of light to be matter. So the point is that all of that space isn't space. It's just energy that's vibrating too fast for us to perceive it or measure it or anything. And that is the energy that we are working with when we want to manifest things. Because it's frequency, it's resonance. And it is actually possible for us to affect frequency and resonance with our own frequency and our own resonance. It's called entrainment. You know, if you have a wine glass and another wine glass and they're the same, and you tap one, or you rub your finger around the rim with some water on it, you make it resonate, right? And the other one will ring because it's in sympathy. And in the same way, if we can learn how to resonate, because we resonate all the time, humans emit an electromagnetic field and it's measurable. If we can learn to work with our electromagnetic field, and we can find out how to work with all of that electrostatic energy that is there in the space that we can't see or measure, but it's there because the physicists and the scientists, they see the effects of it. Just because you can't see it doesn't mean it doesn't exist. And if we can learn to affect how it resonates, it's the resonance that actually produces matter. And if you've ever seen cymatics, like when somebody takes a big speaker and they put Glad wrap, and it's a big round speaker and it's got a depressed thing in it, and the noise comes out, and you put Glad wrap in that, and then you put a mixture of corn flour and water in it, or even just water. Water would do, but sand will do it, or oil, any liquid. And when you play a sound through that speaker, the sound shapes the liquid that's in that bowl into different patterns. And all of that charge and that frequency and that energy that is in the space, which is mostly what matter is, behaves like a liquid. It responds to the laws of fluid dynamics. And so if we can resonate the right way, we're going to shape that matter. That's why I want to explain this to you. And there's a lot to understand. But the first thing is to realize that space is made up of these tiny, tiny particles. In fact, the guy who's sort of been put all of the math and the physics together, and it's really complicated. I don't understand it all, and that's okay. But he's put it together and he says, I'm sure that they're smaller than this, because the evidence that they have in the laboratory suggests that there has to be smaller than a Planck. Imagine that. But the point being that if you understand that matter really isn't solid, it's all of this resonance, it's all of this energy, and just like the liquid in the speaker, when you play different sounds, you get different patterns. When we resonate in different ways, we create different patterns in our lives. And by patterns, I mean matter. Just checking the clock there. I mean the kinds of people and situations that we experience or don't. Everything. And how our bodies are, our physical health, our mental health, our emotional health, our spiritual health. We resonate and we create all of it, and it all interacts. But this is why it's important to understand that all of this stuff we think is solid, it's not. It's mostly this space. And it's mostly full of the stuff that we can't see and recognize because it's vibrating faster than light. So we think it's not there because we can't see it. But it is there. And if we can learn to interact with it, because it's real and it communicates, it does, every day you're getting feedback. And it's not just from the three-dimensional things that you can touch. But you have to learn to understand and recognize and be able to tune in and all of that. Haven't talked about all that yet, but you understand why I want you to explain about these tiny particles. And they make up a fluid, and the fluid responds to resonance, and you and I, we create a resonance every moment of our lives. And we create our bodies, and we create our lives, we create our relationships, we create our financial situation, we create all kinds of things through that resonance. So that is the first little piece of what I'm wanting to explain. You know, I talked all about emotional addiction and how our bodies get conditioned to feeling a certain way. Why is that important? Because the way we feel and the way we think, it's our resonance. It's what we're broadcasting. It's what we create. It physically creates our bodies, but more than that, it creates our life. Moment to moment to moment to moment to moment, everything that we are, everything that we resonate. It's not just here. I mean, where does, if all of that space is inside of your body and all of that space is outside of your body, because the matter's nearly nothing, where does it end? Where do you end? You don't. You're a resonance. Where does resonance stop? Just because we can't measure it doesn't mean it doesn't keep going forever, entangled with the whole universe. That's how powerful we are. So I want to explain this. This is what God of Me is about. So they may be just, talking about these tiny, tiny particles and trying to give you a sense of the enormous scale and how much of what we think is solid matter is not. It's space, and it's just electrostatic charge that makes everything hold together or not. This is how it works. This is really how it works. So, as you can tell, I'm excited. Thank you for listening. Thank you for watching. I love explaining this. This journey is for me, first of all, but I love that you share it with me. And if you haven't checked me out on Patreon/God of Me, please do go and have a look. There are bonuses just for following me for free, because each week I read what I've written. I will not be accompanying the writing with the tears, at least I'm not planning to. Really, it was just complete overwhelm for a moment. And if you support me on Patreon, well then you get inside insights, and I share once a week my journey with you of being God of Me. And it's all got this stuff woven through it. So it's practical application of this stuff that I'm talking about, because this is real to me. This is how I'm manifesting my life, and I'm learning as I go, and I love to share it with you. So join me on Patreon if you wish. Thank you for watching. I so look forward to seeing you again next week. Until then, much love. Bye-bye.